Let's continue to work with these continuous sample spaces. And if you have a die like this one, you have these 6 different outcomes possible from this um, die. If you roll this die, what the sample space will be? Well, the sample space of this will be equal to 1, 2, 3, 4, 5, and 6, which is all the possible outcomes out of this die. And then this is the complete sample space of this event. Let's think that we need to set some event A, and this is the event of interest. And let's suppose that we need a subset of this sample space where all x's or all random variables would be such that that x equals to an even number. In this case, how do you think that the subset A will look like? What is the complement of this subset A, which is A prime? Well, if we toss die to get even numbers, the subset that is, in this case, a subset from the sample space S will be this one, including only the even numbers, in this case 2, 4, and 6. The number 1, the number 3, and number 5 obviously are going to be out of this subset number because they are not even numbers. So the even numbers set is a subset of the original sample space. And let's think that you toss a die the second try and we get some event B. And this event B, let's suppose that is going to be equal to all those numbers that are greater than 3. Now, how will look this subset? Well, if you have this event A with the even numbers and you are going to um, perform another event in order to have all those numbers that are greater than 3, then the subset 4, 6 will be, in this case, the event B. Okay, and this is kind of a brief explanation of how to do a subset out of a sample space. Many of the rules that are basic for this subset construction, and how can we interact with this um, set logic and theory to have all these sample spaces and event topic understanding. Another tool that we can use as a graphical aid to do this union, intersection, and complement operations with sets is the Venn diagrams. Here we have three sets. This is set A, set B, and set C. And we have some numbers that, for example, this number 1 belongs to A, belongs to B, and belongs to C. In this case, number 3 belongs to B and C, but does not belong to A. So to set all these possible outcomes on related to union and intersection and complement of these Venn diagrams, we can have this example. Now, if we have, for example, this A union C, A union C is equal to 1, 2, 3, and then 4, 5, and 7. And is not included the 6. Why not? Because the 6 is not on C and is not on A. So if we are going to join the A and the C subset, we are going to include the 7, the 2, the 1, the 4, the 3, and the 5. The 6 are not part of A, neither part of C. Our part is part of B, but B is not part of the scope of this operation. Now, what it looks like the complement of B intersection A. The complement of B are all those numbers that are not part of B. In this case, out of this boundary, the only number that is part of A and is not part of B is the 4 and the 7. The 7 belongs to A, the 4 belongs to A, but these numbers are out of the boundaries of the B. So these two numbers are the complement of B and are also part of A. So the intersection between the complement of B and A will be 4 and 7. The union between A, between B, and between C is 1. This is the union of these three uh, subsets. Do you think that this is correct? Do you think that the union between A, between B, and between C is 1? You're right. That is not correct. Why? Because the union between A, B, and C will be all the elements that belongs to all three sets. And this will be the total amount of this operation. So in this case, A intersection B intersection C is equal to 1 because the only element that belongs to all these three sets is 1. Okay, so here you have. And the union between A and B intersection the complement of C will be equal to 2, 7, and 6. Now we have union between A and B, but we want all those numbers that are not part of C. So this is 6, 2, and 7 because these numbers belongs to these A and B sets but are out of the boundaries of the C, which are the complement of C. And this is an example of how to work with the Venn diagrams and how to work with some logic about these continuous sample spaces and subsets and the union, intersection, and complement on subsets as the basic operations for them.